Hello everyone, Dr. Guillemette here, coming at you with a new video on the probability of not. So, this is an update of a video I previously recorded that's been pretty popular, but I've broken it up into a short series to better meet my students' needs, giving it an update. Hopefully it's not blurry or the audio isn't messed up. The previous video, that was a couple of the comments. So I wanted to redo this one. The purpose of this video is to find the probability of an event will not occur. Okay, so this is actually a really important idea and simplifies many calculations. So first, we need to start with a definition. So the negation of a set E is known as its complement. Thus, the complement of E is, this symbol is a tilde, A, and we read it as not E. It could also be E with this little apostrophe mark here, and that would be read as the complement of E. All right. Now, this has a very important result, and to understand it, I want to look at a Venn diagram. So here is my Venn diagram with E and all of the elements of the event E inside. And then everything else is not E, all of this blue out around it. Okay? So notice everything is either in E or in not E. It's either in the black area or the blue area. You are either in E or you're not in E. And so this means that E union not E equals the entire universal set. Everything under consideration. All right. So from probability, this implies that the probability of E plus the probability of not E equals 1. Remember, if something must happen, it's 1. And so because it's either E or not E, it must happen. It's the entire universal set, everything under consideration. And so it has to be equal to 1. All right. So this means, by a little algebra, that the probability of not E is equal to 1 minus the probability of E. Okay? Now, this is useful. This is actually useful when it's easier to calculate the probability of E than the probability of not E, which actually is very frequently, especially when you have quantified statements. All right? So, now note, I will do some examples of quantified statements, but I'm going to do that in another video in this series of updating. For now, I just want to do a few examples that do not have quantified statements. So the easiest form of these. So for example, let's say there are 20 heroes in the DC universe without superpowers. And it's at least 20. I actually found a comic book CBR article that had 20 DC superheroes without powers. So I know there's at least 20. Let's say that 6 of them belong to the Justice League. What is the probability that a hero without powers does not belong to the Justice League? Okay? So we want to know what's the probability if you don't have powers, you do not belong to the Justice League. So the probability of belonging to the Justice League is equal to 6 of them that are in the Justice League out of 20 total. That would be the universal set under consideration, which simplifies to 3/10 or 0.3, depending on what your particular professor or homework system wants for an answer. Now remember, the probability of not E is equal to 1 minus the probability of E. Okay? So this means that not belonging to the Justice League is going to be equal to 1 minus the 3 out of 10, which is 6 out of 10, which reduces to 3/5 or 6/10. All right? Which is great. Okay? And because we only have the probability of belonging to the Justice League, this is probably the best way of doing this. Now, another example is, let us discover, right, through some data analysis, that in the Justice League, the following percentages for superpowers are true and mutually exclusive. Now, this is only true for this problem, and we're using it to simplify the process. You can see if you do not have mutually exclusive that some of these things are going to be more complicated and would need a Venn diagram. But let's say that super strength is 25%, super speed is 12%, any type of energy blast power is 28%, mental abilities are 12%, and all types of elemental power are 22%. So we have these 5 different classifications of power. And if I have done my math correctly, this is all going to add up to 100%. Because remember, I said these are mutually exclusive. Okay? It's really important that they add up to 100%. Otherwise, this doesn't work. What is the probability a superhero does not have super speed? Oh, okay. Well, that would be the probability of super strength, or energy blast, or mental ability, or elemental power. And so what I would do is I would add up the other 4 types of powers to come up with a solution. However, that's 4 calculations, right? That's 3 additions of the 4 powers. So it actually is conceptually... It's calculationally easier to consider this as a not problem, because we know that the probability that you have super speed is 0.12. So the probability that you do not have super speed is 1 minus the probability of super speed, which is 1 minus 0.12, which is 0.88. And so we only have 1 calculation here as opposed to 3 additions. So that makes it easier. Okay? If you learn something from, not form, from this video, that makes me happy. Please like and subscribe to keep up to date with my new content as it comes out.